Hello, I wanted to kind of review with you about systems of equations and what we've been doing before I get into substitution. But basically, systems of equations are just where you have two or more equations and you're trying to find the point of intersection. You know, where do they meet? Where do these two lines meet up? If you were to draw them out, and say, okay, they are, this is their point of intersection if it was on a coordinate plane, that kind of thing. Now, there's a couple of ways that you can do this. First off, you can go ahead and say, well, there are going to be coordinates. It's going to be x and then y. Okay, and we did that last week where you kind of saw where they were and you put them together. You can also have the same line and have infinite solutions. Okay, so this is if you have something like y equals 2x plus 8, and then your other line is y equals 2x plus 8. Those two lines are going to run right on top of each other, and as they do, every single place on that coordinate plane that they hit is going to be a point of intersection. So that's why it's infinite solutions. Make sure whenever you're doing yours too that you put arrows at the end of your lines, okay? And then finally, the last one is going to be parallel. Okay, this is actually also called no solution because they never meet. But here's what they have to have. They have to have the exact same slope but different y-intercepts because they have to rise and run at the same rate. So for instance, this one, they are rising at 2 over 1, but they are hitting the y-axis at different points. This one's at positive 3 and this one's at negative 3. Okay? Now, when you're doing these, again, all you're trying to do for systems of equations is try to find out where they meet. You can do this by graphing them. You can do it by trial and error. And you can do it by substitution and by elimination. Okay, so all these are ways that you can figure out where they meet. That's the whole point of this, is finding different methods to find out where the systems of equations meet. Okay, so for instance, this one right here, you would start at negative 3 on the y-axis because that's what it says. You would go up 1 over 3, and then you would have to go back because you run out of room. Okay, so that's the first line. The second line, you're going to start at 1. It's a negative 1 over 1 slope, so you're going to go down 1 over 1. And you can see, okay, exactly where do they meet. They meet at 3, negative 2. Okay, so that was the graphing, and that's what we were doing last week. Now, I'm going to show you another method, which is called substitution. Now, I think it's important that you're exposed to all of these, and then once we learn them all, you can pick how you want to do it, okay? But the first step for this is to isolate a variable. Now, this, we're lucky because they're both isolated, so we can just pick one, okay? I am going to pick it doesn't matter. They're both the same. So everywhere there's a y, I'm going to put 1/3 x minus 3. So where in this equation is the y? Right here, right? So I'm going to put in 1/3 x minus 3 equals, and then what was the other part of it? This is the rest of the equation. Now from here, you can go through and solve. I'm going to add 3, 1/3 x equals negative x plus 4, add x, add x. So that's really 4 thirds x equals 4. Okay, so x is what? 3. That means that I already know one of my coordinates is 3. Okay, so now that I know what x is, I can pick either one of these equations and put that in for 3. Now, to me, looking at it, it's going to be easiest to put it in the second equation because there's no fraction there. So you have y equals negative x plus 1. What is x? X is 3. So now you're going to have y equals negative 3 plus 1. So y equals negative 2. Isn't this exactly where we had said previously that these meet is at 3, negative 2 whenever we graphed it? Okay. So what I'm trying to get you to see is there is more than one way to do this. Graphing is one method, and yes, it does work, but you can also substitute it in if you don't have a graph or graph paper, and you just want to isolate a variable and see. Yes, so see, we had the exact same answer. Okay, and now here is another example. Here's the rules. I would highly suggest that you write these down. First, solve for one variable. Which one of these is going to be easier for me to solve? Well, to me, all I have to do is move this to the other side, and that will give me x equals 4y plus 4. So now I know everywhere in this equation where there is an x, I'm going to plug that in. So 3x plus y equals negative 1. What is the x? The x is 4y plus 4. So right there, I'm going to put in 4y plus 4 plus y equals negative 1. So see, all I did was where there was the x, I put what they told me the x is. Now, you can go through and just solve it normal. 12y plus 12 plus y equals negative 1. Combine like terms, and you will have 13y plus 12 equals negative 1. Subtract 12. 13y equals negative 13. Y equals negative 1. So now I know one of my coordinates. I know that y is negative 1. Now the next thing you can do is you can just pick either equation to substitute it in. Okay, so let's go through what we did. First, we solved for one variable, which was where I took this and moved it over. Substituted that into the other equation, which is where I put it in for x. Solve the equation, which is what I did. Substitute that result into another equation to find the value of the other variable. So now that I have y, I need to find x. I'm just going to plug it into the second one, and I will have 3x plus y equals negative 1. Now, what is y? Y is negative 1. So now I can go ahead and add 1 to both sides. 3x equals 0, and x is 0. So now I know my coordinates. My coordinates are 0 for x and negative 1 for y. That's the most important thing, is we're trying to find the coordinates. So every single time you're doing this, that's what your goal is. When you are graphing, trying to find the coordinates. Trial and error, trying to find the coordinates. Substitution, trying to find the coordinates. Elimination, the same thing. And they can have, again, different solutions, okay? And those solutions can be, okay, you can have a point. So you can have x, y. You can have where that they meet somewhere on the coordinate plane. And I'm just going to say that this is 2, 2. I'm just guessing. That's one way. Okay. Another thing that you could have on the coordinate plane, and it could be the exact same line, which means that they just lay on top of each other, and the solutions there are infinite. Or you could, well, you would have to write every single one of them, but it's where they cross every single place. They cross everywhere because they're on top of each other. And then the last one is parallel. That's when they run side by side. They have the same slope, but different y-intercept. Okay, I hope that this helps you and gets you in a good place for substitution and a review of graphing.